Estimate activity duration is the fifth process, and it estimates the number of work periods, for example, the number of days or number of hours, needed to complete individual activities with estimated resources. This process is important mainly because it provides the amount of time each activity will take to complete, which is a major input into the developed schedule process. The ITTOs for the estimate activity duration process are as follows. And notice that the key inputs are actually the outputs from the prior process. The key inputs are Schedule Management Plan. This plan defines the method used and the level of accuracy, along with other criteria required to estimate activity durations. Activity List. We need the activity list along with the associated activity attributes so we can determine duration estimates for each of them. Activity Resource Requirements. The estimated activity requirements will have an effect on the duration of the activity. For example, if our plan is to assign lower skilled staff to an activity on the project, we may need to extend the duration of that activity due to training requirements as well as the learning curve. Resource Breakdown Structure. Again, this is a hierarchical structure of the identified resources by resource category. The categories could include labor, materials, equipment, and supplies, and is a useful way to organize and report resource-related data. The tools and techniques are analogous or top-down estimating. This is when you use the actual duration of a previous similar activity or project as the basis for estimating the current duration of an activity or project. For example, you know from experience in working on prior projects that building each floor usually takes 6 months. So you use this estimate to help you come up with a duration estimate for this project. Analogous estimating is usually less costly and time-consuming than other techniques, but it is also usually less accurate. It is often used when there is little information about the project. Parametric estimating is an estimating technique in which an algorithm is used to calculate cost or duration based on historical data and project parameters. Parametric estimating uses a statistical relationship between historical data and other variables, for instance, square footage in construction, to calculate an estimate for activity parameters such as cost, budget, and duration. For example, you know that it takes 1 hour for the cable vendor to install 20 meters of cables, so you assign an estimate of 50 hours for installing 1,000 meters. When you think of parametric estimating, think of mathematical calculations. We also take use of the 3-point estimate. The accuracy of single-point activity duration estimates may be improved by considering estimation, uncertainty, and risk. This concept originated with the program evaluation and review technique, also called PERT. For example, in order to get a better understanding of how long it will take to create the foundation for the building, you decide to ask 3 experts for their estimates. This will provide you with a pessimistic, most likely, and optimistic value. With these 3 estimates, you will come up with an expected activity duration using a weighted average. Let's look at this formula. Reserve analysis. Duration estimates may include contingency reserves, sometimes referred to as time reserves or buffers, into the project schedule to account for schedule uncertainty. Contingency reserves are the estimated direction within the schedule baseline, which is allocated for identified risks that are accepted and for which contingent or mitigation responses are developed. Obviously, as more information about the project becomes available, the contingency reserve may be used, reduced, or eliminated. The key output is activity duration estimates, which are quantitative assessments of the likely number of time periods that are required to complete an activity. Duration estimates do not include any lags like what we defined in the sequence activity process. Activity duration estimates may include some indication of the range of possible results. For example, 2 weeks plus or minus 2 days, which indicates that the activity will take at least 8 days and not more than 12, assuming a 5-day work week, and 15% probability of exceeding 3 weeks, which indicates a high probability, 85%, that the activity will take 3 weeks or less.